In this problem, we're given a position versus time graph. We are asked to draw the velocity versus time graph and the acceleration versus time graph, as well as estimating the curves. And in this problem, we have a case that involves simple harmonic motion, and it's going to look something like y is equal to a sine omega t. And in this case, there is a shift, and we essentially have to find that shift, and I have denoted it here with alpha. And it is a periodic function with a equals 1, the period, which is the peak from here and here, is 2. And using these very simple equations for frequency, we are able to determine that the frequency is 1/2, and that gives us an omega of pi. So basically we are using that y is equal to a sine omega t, and we are going to find the shift by finding alpha here, and that shift is going to be minus pi over 2. So basically the position versus time graph, for the function, I estimated it to be y of t is equal to sine of pi t minus pi over 2 to take into account that shift. And by taking the first derivative of that function, I'm able to find the velocity function, and that is over here, pi cosine quantity pi t minus pi over 2. And taking the derivative once again, I get the acceleration function, which is written out over here. And something that has this type of motion, for example, could be a spring, a weighted spring, perhaps dropped down, or a spring attached, a weight attached to a spring that is allowed to fall down. And here we have the velocity versus time graph, and that's the acceleration versus time graph. And the way I got those is by using the velocity function and the acceleration function that I obtained from the position versus time function. And essentially all I did was plug in points for t so that I can get various quantities on the y-axis. So that is how I got all those numbers, and it follows a pattern. For velocity, if you plug in a time, it just goes back and forth for 0, pi, 0, negative pi, and so on and so on. And the same goes for the acceleration graph. And that is about it. Thank you very much.